Hello students, let's start set our lecture which are concerned with the so-called operational method or Laplace transformation method. It should be known, I hope that it is known for you from mathematics, this Laplace transformation. And it is you should remember this designation, capital letter F from P. P its function, it's analogous of T when we consider function of time. Here it's a function of Laplace transformation, it's designated as small letter p. So function, it is designated as capital letter F from P. It's image by Laplace of function by time. You see, F, small letter F from T, it means that it's instantaneous volume from time. And when we would like to find out image of this function of time in the form F from P, we should apply such a mathematical operation. It's integral image of function equal to integral from 0 to infinity from the considered function multiplied by exponent e is the minus pt by dt, where p is just argument of Laplace transformation function. And here p it's presented as a complex volume. It's c plus j omega. And present, you see, it's how this p, this variable, differ from just application of phasors at presentation of currents, voltages, changing by sinusoidal law with the help of a complex number. It will be just j omega. But to take into account transient processes, additional function, real part of this p is introduced. So p c plus j omega, and this presence of this c permits to take into account natural component of transient processes in the considered branches, in the considered schematic. But to apply, to get such an image of function of time, this function of time should meet Dirichlet conditions. It should be known to you from mathematics. So I will not just remind you about it. And if you have forgotten this part of mathematics, please read it one more time to be able to apply this Laplace transformation in electrical engineering. I will try to explain you as much as possible, but I will not give you proofs, explanations, much explanations, only application of this approach to electrical engineering. It's my task. So Dirichlet conditions, it means that this function f from t should have finite number of maximum and minimums and a finite interval as well as finite number of discontinuous of the first kind. And this function f is all from mathematics. It's definition of possibility of application of such an operation to some function. And function phi from t should be limited. So a and alpha are here positive numbers. So it should be this function should be should be less than some such a function. Yes, so it should not tend to infinity in any interval of changing of this function. It means in practical terms. And correlation between original its function from time, f from t, and its image by Laplace, capital letter F from P, is designated in such a way. You see, it's a sign of equality, but these two dots, it means that these functions are not equal to each other, but it is function from time and it is corresponding Laplace image of this function. So it should not be just equality sign, but with these dots we understand how these two functions are connected with each other. And let's consider properties of Laplace transformation. And first property is property of linearity. It means that sum of functions of time multiplied by some coefficient may be presented as sum of the same coefficient and multiplied by images by Laplace of the same functions. You see, it's a property of linearity. So we can it may be formulated as the original's linear combination corresponds to image's linear combination of some functions. Okay, it's also from mathematics. I will not present you with a proof because it is not mathematical course of mathematics, course of electrical engineering, only application of these properties. I just remind you about these properties. Then let's consider images of the simplest function. Some simplest function, we will consider their images. Let's consider at first the so-called unit function. You know, it's designated as 1 from t, and it's equal to 0 when t is less than 0, and it's equal to unit when t greater or equal to 0. This function should be known to you from mathematics. I even do not present you with its graph because it's a very common function and you should understand how to manipulate with it. Let's get image of such unit function. So for this we write down that f from p equal to, like here, integral from 0 to infinity. Then it should be just function multiplied by this e in the degree minus pt multiplied by dt. So function equal to 1, yes, unit, because for interval from 0 to infinity it's equal just to 1 multiplied by this exponential function multiplied by dt. So let's take integral of such a function. It's very easy because it is known that integral from exponential function equal to just this exponential function. But argument here is minus p multiplied by t. So we should, to get this dt from the same argument, we should multiply and divide this expression by minus p. So it will be, when we multiply it, will be this integral will be equal to e to the minus pt, and when we divide it will be minus 1 over p. Okay, and should this integral, we should here use this limits 0 and infinity, and when this limit equal to infinity, this exponential function will be equal to 0, and when this argument equal to 0, so it will be with minus, and minus will give us plus. It will be 1 over p multiplied by e in 0 degree, it's 1. So we've got such integral, it's equal to 1 over p. Therefore, image of this unit function 1 in such 1 from t, it's better to write down, it's equal to 1 over p. So if we have constant, for instance a, we can write down that image of constant equal to a this a multiplied by this unit function, and therefore it is equal, its Laplace image by Laplace equal to a, this coefficient over p. So if we have, for instance, DC EMF, this capital letter E, its image by Laplace will be equal to E over P. If we have constant DC current, its image by Laplace will be equal to E over P. Don't forget to divide constant function by P to get its image by Laplace. Don't forget it. Then let's consider another common case. It's exponential function phi from t equal to e in the degree minus alpha t. To get image of such function phi, capital the phi from p, we should substitute this phi of t multiplied by e in the degree minus pt and multiplied by dt, and we should calculate such an integral. So it will be this function f from t is e in the degree minus alpha t, then it should be multiplied by exponential function from minus pt and multiplied by dt. We can rewrite it as e in the degree minus t before bracket, and in bracket it will be alpha plus p if we've got this minus before this bracket. And to take this integral, we should divide and multiply this expression by minus 1 over p plus alpha, this coefficient. Then we will have d from t multiplied by minus 1 over p plus alpha, and such an integral which be equal to exponential function from minus p plus alpha multiplied by t. And we should take this integral in the limits from 0 to low limit is 0 and high limit is infinity. And you see, when we have this higher limit, this exponential function will tend to 0, and when we have this lower limit, so it will be minus before this function, so it will be minus and minus will be plus, and we will have this coefficient 1 over p plus alpha, and e in 0 degree will be equal to 1. So image of exponential function e in the degree minus alpha t equal to 1 over p plus alpha. And so we can write down a very important expression. We can write down with the help of this property of linearity, we can write down that sum of such function ak multiplied by e to the degree minus alpha kt from k equal to 1 to n will be, it may be presented, such a function from time may be presented as image by Laplace, this sign as sum from k equal to 1 to n, the same coefficient ak over p plus alpha k, because image of exponential function is 1 over p plus alpha. This is important function which we will use later on. Please remember it by heart. Then function 1 minus e to the degree minus alpha t, and with the help of linearity property we can write down that f from p will be equal image of 1 of unit, it's 1 over p, yes, it was here, yes. Then image of this function we can present as here, we can present it as 1 over p plus alpha, and this minus because we have difference of these two functions. And then we can collect, we can rewrite it with a common denominator. It will be p multiplied by p plus alpha, and here we have p plus alpha for this in numerator, minus p here, plus p and minus p, this minus p will be eliminated, and we will have only alpha in numerator. So image of function 1 minus e in the degree minus alpha t equal to alpha over p plus alpha. So let's proceed next lecture. Please don't miss this lecture, and bye bye for now.